Sweet. All right. Hey everyone, welcome to week 7. I hope that everybody watching is having a good week. And yeah, we were talking about the election right before this, so you can vote regardless of who you are voting for. Please vote. It's really important. Just that in theory, this is obviously the pinnacle of what a democracy means is a presidential election in many ways. So it is very important that your voice is heard. And so the worst thing that you can do is not vote. So please vote. And yeah, we wish everyone to be safe during this time as well, just with like COVID and the pandemic and having to go out and vote or even just doing mail-in ballots and all that. So have fun. All righty. Let me get rolling. Sweet. All right. So this week we actually, we kind of deviate a little bit from our planned schedule. And so this week we're actually doing joins. And the reason for this, for those, I guess, watching online who don't know, we do a big C1 project, which is the equivalent of just like a final project that many of our students do when they do the class in person. And so this was a problem that was coming up a lot with people trying to join different data sets. And so we wanted to go ahead and do this now. So basically what joins is, and what we're going to learn about, is how to bring in two data sets, that are different but have similar qualities. Very classic one, very typical would be, let's say, demographics and voting. So, if you have like by zip code, we have, okay, what's the proportion of, let's say, Hispanics, which is, something we're going to look at this week. And how do they, as opposed to proportion of voting, like, trying to put those two data sets together so we can compare the two is basically what's at the heart of join. So it's pretty exciting. Yeah, just all right, for today we have announcements. We do have a quick homework review. It's not going to be too long, and I'll explain why when I get into the announcements. In terms of the group I summarize homework, where we're gonna go over it briefly, but also save it for a little bit later as well. Then we want to have our demo, and then we definitely want to save a lot of time for breakout rooms because exciting announcement. We are making this graph as part of your homework this week, which I sent in the Slack. And this is really exciting for a lot of reasons, I think. Well, one, like I'm very just excited because there's a lot happening in this graph. But when I was looking over the code and thinking about like, can we do is like, we've covered enough to where we can in fact make this graph. And this is a graph that you will see at any major publication easily. And so I'm really, really excited to help make this graph and, just really show how like joining works and how we can use this to, really convey a powerful story. So yeah, if you're watching online, we do link all of our, all of our activities and homeworks and demos within our Google Drive that's linked on the channel page. So please feel free to also do it yourself if you want to, be able to make this graph and or similar graphs, these heat maps. So let me go quickly over this. So yeah, so we do have this schedule change. And so today we're doing this joins with the heat map activity. And the reason why we're doing this is A, because we had a lot of students with joins, and B, we did a heat map workshop on this Sunday, which unfortunately I've not got into upload yet. I was hoping to do it by yesterday, and it just unfortunately did not happen. So I'm sorry. Apologies if anybody was waiting on that. But either way, we thought that the interest was high enough that this would be worth spending a lot of time on, as well as really giving our students really just hands-on work with that. And then our goal is for the next week to kind of review a lot of the concepts that we've already done. So maybe we're not going to learn anything new, but mainly because like group by summarize, group by mutate, as well as a lot of just the joins and whatnot. There's a lot of just edge cases and conceptual understanding that just definitely just takes more than 1 week to learn. So next week is kind of going to be more of a hands-on work, as well as Kevin and I are going to use that to start following up with people just during that hour on the one-on-ones, on their C1s, just to continue to help them. Because at that point, we think you will have, at least for all the projects that we've seen so far, you will have covered everything technically that you need for your project. It'll just kind of be coming along to whether it's still trying to find data or having some problems like reading it in or whatnot. We just want to be able to help you with the more just pragmatic components of your project. So that's kind of what the plan is for next week. Yeah, which kind of goes straight into the C1 for next week. Also, in terms of Kevin's office hours, they've been pretty sparse, to say the least. I think that's kind of an understatement. So we're probably going to actually not have him do office. I'm probably going to have 1 office hours a week where either Kevin or I will be there. And or if we see a lot of demand, we can both be there. So if you are wanting office hours but not being able to make it to the normal times, feel free to emails, we can totally set up a quick Zoom one-on-one, and or we can also respond to questions in Slack or at the email. Particularly if you're watching us online, you can always just email us at the beginnR.workshops@gmail.com. We'll be more than happy to help you out with whatever problems you're coming across. Cool. All right, let's do our homework review. And then, yeah, I guess like the next slides are demo and breakout room. So we'll just go to R now real quick. Bang. Boom. Yeah, so as I mentioned before, I'm not going to spend too much time on our homework of group by summer, even though this is really, really important. But if we're going to be doing this more next week just to really kind of just get, this is something that you just have to work through. It helps to understand it at a conceptual level, but it's far better, to practice it and just, keep doing over and over, which you'll have to do either way as just if you do pursue data science. But I did want to go to the final problem. It's kind of breaking down what exactly is happening here. And so we have our empty cars and we wanted to group by cylinders display, which is giving us every single pair of these two. And this is a little bit of an interesting concept, mostly because displacement's not a discrete variable. So, that's something that like makes it a little bit trickier, but we felt like there was enough within each group to where it was worth it. And also kind of gives us a much better comparison of the variables, like in terms of like real life. And then we did summarize by mean miles per gallon, and we did mean displacement. And then we want to make a new one, which was cylinder, and we want to reorder it by the cylinders by the mean miles per gallon. And so we had to ungroup it. And so this is just, this is kind of like, this was less pragmatic, but more just because we wanted to highlight a concept, and that being, you have to, when you do a group by, you typically want to ungroup it if you plan to use it in the future, just because if you try to do further calculations, it will still abide by this group by, and it's very easy to forget, and it's kind of hard to figure out why your code's not working if you're several hundred lines in and you forgot that you didn't ungroup something that happened way up higher. So that's just something that we wanted to mention. Yeah. I hope this wasn't too troubling. We didn't want this one to be too hard. There's a lot of, group by summarize can still be a very tricky concept. So if it was tricky, no worries. That's the point of next week. We definitely want to make sure that people are pretty solid on this concept. But yes, let's go quickly to our demo again this week is pretty short, mostly because the challenge, which we're pretty excited about, is it is challenging. You can do it. It is challenging, but we do really want you to spend the time and be able to reference to us if you have any questions. But so basically, all that joins are within dplyr, but again, dplyr is a sub package that you can find within the tidyverse like umbrella package. Is that you basically have two data sets, right? The idea is to put them together. And the way you do that is you join them by a variable. So, a variable or, a column that has unique values that exist in both data sets. And so, a lot of easy things that we can think about are like social security numbers, zip codes. You can even think of usually names work, but that being said, if we're looking at particularly large data set, so my name is, Nicholas Rodriguez, which, while I love my name, there were two guys in my relatively small high school who also had the exact same name. So you can see how when you're joining data sets, if you're saying, okay, I want you to get the Nicholas Rodriguez from here, the Nicholas Rodriguez from here, but there's multiple Nicholas Rodriguezes, that's where we could run into some problems. So it's really important that you have a unique identifier, that's unique to each separate row. That's really, really important. So yeah, that's kind of the first kind of component to it. Yeah, and again, I stress that, right, it's really important that the values are unique and also are the same. It will join them exactly as they are. So capitalization can throw it off, or maybe extra spacing, or sometimes if you have let's say you have numbers, 1001, but then one has 001001, those 00s at the front, that padding would throw it off. So you definitely want to make sure that's the exact same. That's the number one tricky part when it comes to joining things. Yep. And so then you can choose two data frames by this value. So by that, that column these unique identifiers that exist in both data frames. And you also want to choose a function that's appropriate to your outcome, which won't make sense right now, but it's going to make sense in a second because there's multiple ways that you can join things. And if you've done ever SQL queries before, you kind of know how this works. And just at a conceptual level, it's kind of let's say, we have a bunch of names here, but only some names here. Which names do we want to keep? How do we want to join it, etc. There's this number of functions that we're going to go through that will help us distinguish what exactly we're trying to get. And then finally, yeah, the final result is you have your two data frames. You have both columns, but you only have one unifying column left. Right, which makes sense, right? There's no point of having like two columns that are like zip codes or two columns that are like social security numbers or what have you. So, but the idea being that you now have one single table that has all your information, which will let you do, you can do group by summarize, you could count it, you can do a lot of really cool things with this. All right, so let's go ahead and take a peek at the joins as well as just the data sets we're using. So left join is the one we're going to cover the most, which I'm really going to like stress, is the one that you use by and large, I would argue 85% of the time. It is, it's pretty, the other ones like have their purposes, but inner join, or sorry, left join typically is useful. So the two, just data sets we're looking at, we're going to keep them small. It's a little bit trickier. It's, if I was asking you to compare these two, like you don't need to do R, you don't need R for this. Like you could just do this in your head, but it's a little tricky to compare when it gets big. And I just want you to kind of conceptually understand this. So we have one that says band members where we have, Mick Stone, Mick who played in Stones, John who played in the Beatles, Paul who also played in the Beatles. And then we have the same names and said what they actually played. And so here, right, what's our variable, our key variable? It's the name. We have a unique name, for each person in the band. And, while, right, I guess names won't always apply. Just for the sake of this, let's pretend that these were the only people with those names in the world. Like this John is referring to that John. Yeah, so let's go ahead. So I put all the functions that we have, and we're going to just go through them one by one. I'm just seeing exactly what they do. So left join keeps, we're joins the variable presence in the first column. So basically, in this case, we're piping our main data set is band members, right? Which is this babe, this guy up here. So we have the name and the band. And so you're doing left join by band instruments. So this is our second data set. And then by, and this our variable, our variable name is name, right? I guess it's a little confusing. Our variable name is name. Right, so we're saying we want you to join these two, and we're saying the common, the common factor, the common variable are the name column. So we have name here and name here. Actually, one quick note that I did not include in the notes now I think about is it's pretty easy when they're the exact same name. They don't have to be. There's actually a way to do it where you do by C, and then like you would basically do by C name. Let's say this was first name was the name of the first one. You can do it like this as well. It's also very easy just to do it straight by just one. So, but you can do it the other way, and you can sometimes see that when people don't want to change the name column. But still, I would recommend just mutating sometimes and just quickly rename it to make sure it's the exact same. So you can just do it like this. But anyway, so we have Mick Stones, John Beatles, Paul Beatles. So these three names are the ones that we had in our first band members, right? So this is what we've decided. This is what the left one is saying. We want the ones from this first data set that we had. And the way that you can think about this is imagine that you have the two data sets together, and one, like the left one is the first one and the right one. It's kind of like making a Venn diagram, right? To where you kind of overlap it. And we're saying we only want now this circle. There's some really, really good graphics on the internet that if you just want to look up like difference between joins and Google it, it'll show you kind of visually, like, right, Venn diagrams, you have these two circles, like which join you're doing in terms of like all the ones here. So in this case, we kept these three names, but we did not use Keith from band instruments because that, that was not, we were using our name is what we're joining, but it wasn't present in this first one. And you can also see Mick didn't exist in these band instruments. Like we don't know what Mick plays. And so that's why we have this NA. Yeah. If you have any questions, please feel free to send them in the chat about this part, as well as, and/or if you're online, just leave in comments or shooting us a quick email. We'd be more than happy to respond. Yeah, cool. So that's the one you'll use most of the time. Right join, it's pretty obvious. It's the opposite, right? So right join would say, I actually want the names that are within here, band instruments. And so really, like if I had put band instruments here and band members down here, I could just done left join. Sometimes, for whatever reason you want to use right join, go for it. But here, let's see again. So we have John, Paul, Keith, and those were the three that we had in our second, our band instruments one. But here again, we have, we have now all they play because that's what we kept, but we don't have a band for Keith because Keith, in this case would be, I believe is it Mick who we don't have here? Yeah, we have Mick and Keith are the two names that are different in each data set. Inner join keeps only the values present in both cases. So if you think about like that Venn diagram, it's just the area in the center, the overlapping area. So in this case, we have John and Paul who exist in both of them, but both Keith and Mick are taken out. So that's, that's just like basically only keep those unique variables where we have that are present in both data sets. And then last but not least, full join just does it all. Full join just like literally just like basically just like stacks them right on top of each other. And so yeah, and you can see here we have, this one will have the most NAs, which in this case isn't a lot, but like on a big data set, this could certainly act up. So in many ways too, joins can kind of act as filters, right? In a way, like you're kind of saying like, I only want values where I have this or I have that. And so that's something you definitely want to keep in mind. Cool. Do you have any questions that people would like to ask out loud? If not, I think we're good. Yep. And so for those fun online, please feel free to do the to take a stab at the graph. We're going to spend a lot more time like in person with our class, but obviously we don't record that. But we really do want to help you to learn how to do these heat maps because it's an incredibly powerful tool. And really, if you've been following with us well, there's nothing in there. With these a couple of bells and whistles, but we guide you through those, I think, pretty well. So with the extension of those, that fundamentally what's at the crux of this graph, you have more than enough skills to do. So we really hope that you take a stab at it. Yeah. Thanks for watching, and we hope to see you all soon. Have a good one.